Yeah, hi and welcome to part 6 of the supplementary coding along video series for the Build a Large Language Model from Scratch book. My name is Sebastian Raschka and I'm the author of the book. And yeah, these supplementary video series are meant as a additional resource where I guide you a bit through the code in a more casual way. So in part 5, what we have done so far is we pre-trained the GPT model. And now we can finally take advantage of that and build a interesting application on top of this model. So let me just show you where we are in this book. So in the beginning, we coded the data sampling, the attention mechanism, and the LLM architecture. And then in part 5 here, we essentially pre-trained the model. But pre-trained models are only, I would say, the beginning. So with a pre-trained model, they are quite interesting, but they are just the base model or the foundation for more interesting applications. So for example, when you use something like ChatGPT, you're probably thinking of a model that is capable of interacting with a user by addressing or answering to certain queries. For example, summarize this text, tell me who was the first president of the US, or other kinds of things. So translating, summarization, writing a paragraph, rephrasing things, answering questions. These are all things that you would expect from a chatbot or a personal assistant. And this is what we are going to do in part 7. First, so in this part, in part 6, I want to show you a simpler application of fine-tuning. So part 6 and part 7, they will be both concerned with fine-tuning the model. So fine-tuning essentially means that we're taking the pre-trained model and train it further or fine-tune it for a certain target application, where a target application could be classification or developing this personal assistant. So in this case, this will be called instruction fine-tuning, as we will see in part 7. But I want to start with fine-tuning this GPT model that we pre-trained, or essentially also the model where we loaded the pre-trained weights from OpenAI as a classifier, because I think this is a great introduction to fine-tuning. And it's also, by the way, one of my favorite applications of LLMs or small LLMs, because it really shows what we can do with smaller models, because not every application in reality requires a general chatbot. There are so many applications in this world, especially in the business world, where you just need a prediction. You don't need necessarily something that gives you a text response or that can do multiple things at the same time, like summarizing and translating text. Sometimes you just need a model that predicts something, for example, customer sentiment, or I don't know, like stock market trends or something like that. So there's an infinite amount of things you can do. In this chapter, we will focus on a simple application of email spam classification, because you probably all are familiar with emails and spam emails. And traditionally, the problem of implementing a spam classifier was done with more traditional models. So even going back to like logistic regression or naive Bayes classifiers and so forth. If I recall correctly, one of my first tutorials even was a naive Bayes classifier. It just comes to mind while I'm talking here, but maybe I can that's the same problem again. Maybe I can just show you and find it if it's not too distracting here. But so one of my earliest blog posts, I think, was on naive Bayes. Here it's 2014. So traditional methods for developing a spam classifier. And these are methods that are very fast. So they're very popular in cases where you have a large customer base. So if you are running a classifier on your computer, I mean, you don't really, the only limitation is the hardware you have. In a small LLM like the one we developed before, it is fine to run on a local computer. But if you are, for example, a big company like Google, and you have millions of customers who use your email application, you have to be also concerned with how can we reduce cost, or how can we make sure that this scales to millions of users. And simple models are actually quite nice for that. And even if you are not concerned with cost savings or efficiency, simpler models like naive Bayes or logistic regression are still great for establishing a performance baseline, because they are usually simpler to implement. And so when I develop a new application, I usually start with the simplest model, and then I look, oh, I get so and so % accuracy, and then I try to use more complex models or more expensive models and see how much are these models improving over my baseline. So it's actually always a good idea to also start simple. But in this book, because it's a book focused on large language models, we will be actually focusing on adapting the large language model from the previous chapter, the pre-trained model, and fine-tune it as a classifier on a spam classification problem. And spam classification, because it's easy and it's familiar, but you can also do this for any type of classification task, which is quite interesting. And these models are, you will see, actually quite good for classification tasks. I would say let's get started. So here we will be first focusing on preparing the data set. And so also maybe I should show you one more figure. So what we are going to do, where we are here. So this chapter itself, there will be several stages. So the first stage will be concerned with the dataset preparation, and we will start with that. And later we will talk about how we set up the model, and then essentially how to fine tune and evaluate the model. So one step at a time, we are now focusing on the dataset preparation part here. And so for that, I will just show you the code here, and I will just briefly talk about it. Let's see if this URL works. So I'm using a data set from UCI. So UCI is, I think it doesn't work like that. UCI is a repository, a machine learning repository that has been around for many, many years, where you can find public data sets. They're just, easy off-the-shelf data sets. And I was trying to find a data set that is relatively small. Let me see if this works, because I have the zip file. I have the zip file link directly. So maybe I should just search for this. Because I don't want to, here in the browser, download the zip file. I just want to show you the data set. Yeah, this one. So we are going to work with this data set, which is very simple. Just a small email, not even email, like a SMS text message labeled messages data set that consists of spam and non-spam. And our goal is to classify spam spam messages. And this would also apply, of course, to email and other problems. I do, in fact, have bonus material where I'm applying this to movie review data set. So in this GitHub repository for this book, where I keep my bonus material, I will talk more about this later. I do have also 50,000, the data set of 50,000 movie reviews as another example, but I want to keep this relatively small, this data set. It only has the 7,000 examples, so it's faster to train, and I think it's sufficient to illustrate how you can adapt LLM for classification tasks. And so what you're seeing here is just boilerplate code to download the dataset. You could technically also just do that manually. So this is just to automate it. So it will download this zip file from the spam collection website here. So if compared to clicking download, it's doing this in Python, and unzipping the file, and then adding making sure the file path is correct. So the file path will be SSM spam collection TSV. So this is a tab separated value file. It's like a CSV file, but instead of comma separated values, it will be tab separated values. So I will show you how this will look like. So here we have this folder, and this is a small data set, so I can just open it here. In general, I don't recommend just opening files like that, because when they are large, that will or can crash your compute memory if you have like millions of rows. But yeah, as we can see, we have ham or spam, where ham means non-spam. And then on the right-hand side, we do have the text message. And that's how the dataset is structured. So next, since we have loaded this now, so next it's not a bad idea to load this in Python to also make sure it's formatted correctly. And by the way, let me also show you, before I import this pandas library, let me show you the packages that I'm using in this book or in this chapter right now. So we will be using matplotlib later for visualization. the NumPy array library, of course, that underlies matplotlib and pandas. Pandas is a data frame library. It's on top of NumPy, adding a data frame format. Nowadays, there's also another library called Polars, which is faster. It's a Python library that also implements the code in Rust underlying the Python implementation, which is similar to what TikToken is doing. But I'm using pandas here because we just really only need very, very basic things, and it's a very simple data set. So it's going to be done in half a second. So it doesn't matter whether it's done in half a second or 0.1 second, it's instant anyway. And pandas is, I think, still more popular. So yeah, that's why I'm using pandas. We still need TensorFlow, because we're going to load the pre-trained weights from OpenAI that we talked about in the previous chapter and that we used in previous chapters. And then, PyTorch for the GPT model and the fine-tuning. Okay, so just for reference, the software versions I'm using. But like I mentioned before, you don't have to have exactly the same versions. It's just here as a reference in case something goes wrong. You know what I used, and if you want to exactly replicate things, if things break. So we are first importing pandas. It's like an array library for nicely loading the data set. So I will use the read CSV function. So the CSV function is usually used for loading CSV files, like the name implies, but you can also change the behavior to load tab separated files. So tab separated, you couldn't really see it here because it looks nicely formatted, but maybe I can, let me see if I can do it like this. Maybe the first 5 lines of this data set. It's called SMS spam collection, and then there. So yeah, so you can see this is just like a bash command, and you can see there's like a tab instead of a comma separating this column and this column. So here we see there are 2 columns, but when we are looking at it in text format, that's only one line, and the column is this tab essentially. And so we're saying this tab character is separating our columns, and we don't have a header. So header means that we don't have like a column label. It's really just, text. So the first line really starts with a data sample. And so we can give it our own column label. So we can call it label and text, where label is ham or spam and text is the message we want to classify. And then I can print it here, and I can see there are 5,572 rows and 2 columns. Looks good to me. And we can also count how many of those are spam and not spam. So what I can do is I can do label and then value counts. And so this will be listing how many non-spam and spam messages we have. And you can see this is like an imbalanced data problem. So there are many more non-spam messages than spam messages. And this will make it a bit trickier to evaluate the model and the performance, because we can't just use accuracy then. there are measures like balanced accuracy, precision recall, like ROC curve and so forth. And so this would be a different type of beast. So for that, maybe just let me see if I can recommend something, but there's a library called imbalanced learn, for example, that is specialized in working with imbalanced data. And if you are interested in, if you are interested in model evaluation and machine learning in general, I do have a paper, or let me see, here on archive. That's not the right link. Let's just search for it. So this one, it's like a many-page article. It's probably, 50 pages almost, where I discuss more about model evaluation and the different metrics and so forth. So if you're interested in that, I highly recommend, reading this in detail. For this chapter, I will keep things simple. So I don't want to, spend 5 hours talking about model evaluation and everything, because then otherwise this will be way too long and it won't be about just LLMs anymore. It will be a general machine learning and deep learning lecture. So what I will do is I will balance this data set, which means that we will make sure that we have the same number of non-spam and spam messages. So I will reduce the number of non-spam messages to 747 so that we have a balanced data set, and it will make just talking about it a bit easier. So it's making the problem a bit simpler here. Because, I want to focus more on the LLM part than, all the other evaluation parts. Evaluation is a very important topic. It's, I would say, just a topic for a different book or a different course and so forth. So I will probably in the future one day talk about it separately. But for now, let's make this problem simpler so we can focus on the LLM fine-tuning. So what I'm going to do is I'm defining this function here, create balanced dataset, which will make sure that non-spam and spam messages have the same number of samples. And so what I'm doing is I'm first counting how many spam messages we have. I can just show you here. So we have 747 spam messages. And then what I will do is I will sample the same number of non-spam messages. So here the sample function will take a random sample of 747, because that's what we have here. And we set a random seed so that when you execute the code, you get exactly the same samples. So to ensure that we all work with the same subset. So when I just execute this, I should probably, because I'm improvising here, should probably assign this to a variable. So yeah, you can see we have 747 non-spam messages, ham. And then what I'm doing is I'm concatenating them into a new data set. There might be more efficient ways to do this, but it's such a small data set that we just keep this one and concatenate this into a new data set, which is then our balanced data set. So you can see after creating this balanced data set and looking at the new label counts, we can see we have 747 non-spam and 747 spam messages. Now, there's still one thing that I would say kind of bothers me about this. So when I go here, balanced. So one thing is that the label is text. And so to make it easier to work with, I usually recommend converting this into a label, an integer label, starting at 0. So you can think of this integer label then as token IDs. So essentially what's interesting is here, everything we are doing is we just want to classify whether something is non-spam or ham or spam. So we have two classes, ham and spam. And so before we wanted our LLM to deal with all kinds of words in the vocabulary and output all these words. Now we can make the problem a bit simpler. So instead of having these token IDs going from 0 to 50,257 in the output layer, we can have in the output layer only 2 token IDs, 0 and 1. We have to be a bit careful because our LLM will still work with the same input vocabulary because it still has to process the input text, but the output can be simpler now. We will get back to that later, so I don't want to say too much about this yet. We will get back to that here in this part, modifying the model for fine-tuning. But here, what I'm doing is I'm essentially assigning these labels 0 and 1 to the label column. So what I'm doing here is using the map method. And so first of all, we have the label column. We only focus on the label column. And map is mapping the values using a dictionary. So our dictionary, our mapping dictionary, let's call it map dictionary. So this would be this one here, where we say everything that is ham should become 0 and everything that is spam should become 1, like I'm showing you here. and this will execute this automatically for the whole data set. So let's execute this, and then I can double check it. So you can see now we have these tail and head, by the way, are the first 5 and the last 5 entries. Can also maybe just to make sure, let's use this one. Everything looks correct. So we can see we have now labeled 0 and 1 instead of ham and spam. Yeah, and so we're almost done with the section. That is how we first process the data set to make it, make it nice for further processing. And then the next one I will introduce is splitting the data set. So this will split the data set into subsets. So we will have a training set, a validation set, and a test set. So the training set is for training the model. The validation set is for tuning. So some people also call that the tuning data set, where when we are training the model, we look at the validation set to kind of estimate how well is our model generalizing to data that it doesn't see during training. Because if we only look during training and on the model overfits, we will get something like 100%. But then in reality, when the model sees new messages that it hasn't seen during training, we have no idea how well it would perform. So that is why we have the validation set, so we can have an estimate during training how well the model performs. And then we can also meddle with the model. We can fine tune it, we can optimize it, and use the validation set to see whether our tweaking, our changing of the hyperparameters makes an improvement or not. And then once we are done with everything, we use the final test set. Because when we use the validation set multiple times, it kind of like gets biased. I talked more about this in my article here, the model evaluation article. So we at the end want to have an unbiased or like an independent test set that we haven't used before during the training procedure. And so how we do this is we take a portion, so train end, so maybe going through this sequentially. First, we shuffle the data frame. So this is just one way to shuffle a data frame in pandas. So we say sample and we use fraction 1. So the fraction is how much of the data set, and 1 means the whole data set. And for example, 0.5 would mean half the data set. So what we are doing is we are sampling. It's kind of weird to write it like this, but what's happening is we are sampling from this data set, considering all the rows, and this will essentially shuffle it, because we are just drawing the rows in a random order. And then we calculate the split indices. So we say that, for example, train fraction could be 70%. So it could be, for example, 0.7, and we could say 0.3 or something like that. So that will mean 70%, or let me do 2 here. So 70% of the data, this is the position where we have 70% of the data. So then we extract it. And then from this position, considering another 20%, so this is where the validation ends. So maybe in simpler terms, if we have 100 examples, the train end would be at 70. And then the validation end would be 70 plus the 20. So this would be at 90. Index 90. So if we have 100, 70% for training, then 20% for validation. So the position is here, 90 to 70 to 90 will be used for validation. Let me write this like this. 1 to 70 for training, 70 to 90 for validation, and then the remainder, we have the test set, the remainder, this will be then 90 to 100. So the remaining 10% will be used for testing. So that's just how we subdivide the data set. And so let's do this and apply our random split function with 70% training data. Here I'm using 10% for validation, so it's basically more like this. And then 80 to 100 for testing. And why these ratios? This is again a hyperparameter. Usually 70-80% is a good number for training. If you have a large data set, you can also make the training set smaller. But yeah, it really depends on the application. In this case, 70% is reasonable. 10% for validation. I would say the test set is a bit more important than the validation set because that gives you the final estimate. So I usually make the test set a bit bigger than the validation set. Some people do it differently. They would make multiple validation sets, for example, and rotate them. So it really depends on how much you work on the hyperparameter tuning. So the more tuning you do, usually the more validation data you want during the development to make sure you don't overuse a certain validation set. But yeah, in our case, it's a very small problem, so it should be a fine ratio. And yeah, just let's double check how they look. So here, by the way, I'm also saving them as CSV files so that later we don't have to go through this whole procedure here again if we want to come back to this and just load the data set from these files. And personally, I also like to do that when I, for example, write papers and so forth. When someone wants to reproduce my results, I can share these files with them. So for example, yeah, you can share the procedure, but let's say someone makes a typo or forgets the random seeds somewhere, you would get different results. So in that case, I like to always, save this for record keeping, and so that I know exactly what is used for training, validation, and testing. So we have 1,045 data points for training, validation, DF. We have 194 for validation, and then the test, DF. We have 300 for testing. Okay, so this is it for this part on the dataset processing. And in the next section, we will talk about setting up our data loaders, and then later, of course, setting up the model itself.
Get this book at Manning.com.